Good morning! Welcome to Mathematics 8 Quarter 3 Week 2. Module 1 Axiomatic Structure of a Mathematical System. Lesson 2 Defined Terms, Undefined Terms, Postulates, and Theorems. I am Marinol B. Lisboa of Wanari National High School, your mathematics teacher. Geometry relies on terms such as point, line, and plane for a common understanding. Since these terms cannot be described using other known words mathematically, they are called undefined terms. So a point has no dimension. It is represented by a small dot. Figure 1 shows point A. A line has one dimension. It extends without end in two directions. It is represented by a line with two arrowheads. This is figure 2, line 1 or line BC. A plane has two dimensions. It is represented by a shape that looks like a floor or wall. You have to imagine that it extends without end. So on figure 3 class, you can see there the plane M or plane DEF. Okay, for postulate and theorems, a postulate is a statement that is assumed true without proof. Listed below are 6 postulates and the theorems that can be proven from these postulates. So for postulate 1, a line contains at least 2 points. Of course. Postulate number 2, a plane contains at least 3 non-collinear points. And for postulate number 3, through any 2 points, there is exactly one line. Postulate 4, through any 3 non-collinear points, there is exactly one plane. Postulate 5, if 2 points lie in a plane, then the line joining them lies in that plane. Postulate 6, if 2 planes intersect, then their intersection is a line. A theorem is a true statement that can be proven. So for theorem 1, if 2 lines intersect, they intersect at exactly one point. For theorem 2, if a point lies outside the line, then exactly one plane contains both the line and the point. And theorem 3, if 2 lines intersect, then exactly one plane contains both lines. Letter B, topic would be segments, midpoints, and rays. The concept of lines is straightforward, but much of geometry is concerned with portions of lines. Some of those portions are so special that they have their own names and symbols. So we have first, or letter A, is the line segment. It is a connected piece of a line. It has 2 endpoints and is named by its endpoints. Sometimes the symbol line written on top of 2 letters is used to denote the segment. This is line segment figure 1 or line segment CD. It is written CD. Technically, CD refers to point C and D, and all the points between them, and CD without a line refers to the distance from C to D. Note that CD is a piece of line AB. For postulate 7 or ruler postulate, each point on a line can be paired with exactly one real number called its coordinate. And postulate 8 or the segment addition postulate, if B lies between A and C on a line, then AB plus BC is equals to AC. For midpoint, a midpoint of a line segment is the halfway point or the point equidistant from the endpoints. So theorem 4, a line segment has exactly one midpoint. Okay, for letter C, and that is a ray, is also a piece of a line except that it has only one endpoint and continues forever in one direction. It could be thought of as a half line with an endpoint. It is named by the letter of its endpoint and any other point on the ray. The symbol arrow written on top of two letters is used to denote that ray. Okay, it is written as ray AB for figure 8. This is ray CD for figure 9. So it is written as ray CD or ray DC. Note that the non-arrow part of the ray symbol is over the end point. For letter C, we have angle pairs created with a transversal. A transversal is any line that intersects two or more lines in the same plane but at different points. Take note, it intersects two or more lines. A transversal that intersects two lines forms 8 rays. 8 angles, I should say. So certain pairs of these angles are given special names. They are as follows. Corresponding angles. These are angles that appear to be in the same relative position in each group of 4 angles. Look at this figure. In this figure, we have angle 1 and angle 5 are corresponding angles. Other pairs of corresponding angles in the figure are angle 4 and angle 8, angle 2 and angle 6, and angle 3 and angle 7. Figure 2. A transversal intersecting two lines and forming various pairs of corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and consecutive exterior angles. Alternate interior angles are angles with the lines being intersected on opposite side of the transversal and are not adjacent. So in figure 2, angle 4 and angle 6 are alternate interior angles. Take note, class. When you look at the figure, these are the angles inside the transversal line. So we have your angle 4 and angle 6 and also angle 3 and angle 5. Nasa loob siya. Okay. So for alternate exterior angles, these are angles outside the lines being intersected on opposite sides of the transversal and are not adjacent. So in figure 2, angle 1 and angle 7 are alternate exterior angles. Also, angle 2 and angle 8 are alternate exterior angles. Consecutive interior angles or the same side interior angles. These are interior angles on the same side of the transversal. In figure 2, we have angle 4 and angle 5 are consecutive interior angles. Also, angle 3 and angle 6 are consecutive interior angles. Consecutive exterior angles. These are same side exterior angles or are exterior angles on the same side of the transversal. So in figure 2, angle 1 and angle 8 are the consecutive exterior angles. Also, angle 2 and angle 7 are consecutive exterior angles. Okay, so we also have the parallel postulate. For postulate 11, we have parallel postulate. If two lines are cut by a transversal, then the corresponding angles are equal. So what are the consequences of a parallel postulate? Postulate 11 can be used to derive additional theorems regarding parallel lines cut by a transversal. Because the measurement of angle 1 plus measurement of angle 2 is equals to 180 degrees, and measurement of angle 5 plus measurement of angle 6 is equals to 180 degrees, because adjacent angles whose non-common sides lie on a line are supplementary. And because measure of angle 1 is equals to measure of angle 3, measure of angle 2 is equal to measure of angle 4. Measure of angle 5 is equals to measure of angle 7, and measures of angle 6 is equals to measure of angle 8. Because vertical angles are equal. All of the following theorems can be proven as a consequence of postulate 11 or the parallel postulate. While theorem 13 or the alternate interior angles theorem states that if two parallel lines are cut by a transversal, then alternate interior angles are equal. While your theorem 14 or alternate exterior angles theorem, if two parallel lines are cut by a transversal, then alternate exterior angles are equal. Theorem 15, same side interior angles theorem. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. Because when we say supplementary, the angles are equal to 180 degrees. Same is true with theorem 16, same side exterior angles theorem. If two parallel lines are cut by a transversal, then same side exterior angles are supplementary. The above postulate and theorems can be condensed to the following theorems. Theorem 17. If two parallel lines are cut by a transversal, then every pair of angles formed are either equal or supplementary. Theorem 18. If a transversal is a perpendicular to one of two parallel lines, then it is also perpendicular to the other line. Okay, for letter E, we test or testing for parallel lines. Postulate 11 and theorems 13 through 18 tell you that if two lines are parallel, then certain other statements are also true. It is often useful to show that two lines are in fact parallel. For this purpose, you need theorems in the following form. If certain statements are true, then two lines are parallel. It is important to realize that the converse of a theorem, the statement obtained by switching the if and then parts, is not always true. In this case, however, the converse of postulate 11 turns out to be true. We state that the converse of postulate 11 as postulate 12 and use it to prove that converse of theorems 13 through 18 are also theorems. For postulate 12, if two lines and a transversal form equal corresponding angles, then the lines are parallel. This postulate allows you to prove that all the converses of the previous theorems are also true. Theorem 19. If two lines and transversal form equal alternate interior angles, then the lines are parallel. Theorem 20. If two lines and a transversal form equal alternate exterior angles, then the lines are parallel. Theorem 21. If two lines and a transversal form consecutive interior angles that are supplementary, then the lines are parallel. Theorem 22. If two lines and a transversal form consecutive exterior angles that are supplementary, then the lines are parallel. Theorem 23. In a plane, if two lines are parallel to a third line, the two lines are parallel to each other. Theorem 24. In a plane, if two lines are perpendicular to the same line, then the two lines are parallel. Okay, for our assessment, for 10 minutes, please choose the letter of the correct answer. Write your answer on one whole sheet of paper to be passed next retrieval. There are two columns on next page. First column contains the questions, and on the second column contains the pool of answers. Good luck and let's do it.
Ganyan to madamdama boses yun.
Okay, so you can screenshot this or print screen this assessment so that you can continue later on. Okay. So thank you and I will leave you this quote. Narigatibiyag ubing, especially pandemic, ngam no agtitinulong oray sang kabasit nga banag nga nasaya at mapalag-an tibiyag. I hope you are catching your lessons as well as I try to do my best to make this video lesson. Good luck and mabuhay! Once again, this is Marinal Bilisboa, mathematics teacher of Wanari National High School.